So this week is week 6, I guess. So let me show you the stuff. So in week 6, I will be covering this material here, right? So it's basically maximum likelihood estimation. There's only one video you had to watch. I hope you guys watched the video on maximum likelihood estimation. So I will briefly go through that video, and then I will try to do as many examples as I can. Now, just a reminder about quiz 5. Quiz 5 is based on point estimation, and I did 20 examples on quiz 5, if you may recall, right? So you should have no excuse for not doing well. I mean, I have not been very happy with the performance of you guys so far. I mean, the average is like 64 or 65 out of 100. So that means only like 64 or 65% of you have been getting the correct answer for the quizzes so far, right? So, but I mean, each of the quizzes I've given you, I've done plenty of examples, like, so I don't know what the problem is. I mean, maybe I think I suggest you go through all the examples I've done for the particular topic. You shouldn't have so much trouble doing the quizzes if you go through the examples I have done. Anyway, for the quiz this week, right, I've done 20 examples. I think that is plenty. So please try to go through those examples before doing the quiz number 5. Okay. And if you have trouble if you have trouble with quiz 5, of course you can contact me 24/7. Okay. I mean, I'm here all the time for you guys. So please feel free to contact me by email, Skype, Zoom, or phone. All right. All right, guys. So let's begin. As usual, any questions you guys have, please use the chat room. Right. All right. Let me change the camera. Here we are. Hopefully you can see this. I don't know. Let me adjust this. This is the best camera I can buy, but is this okay or not? Let me put the code. This is okay. Okay. Let me know if you can't see it clearly. All right. Now the thing is, so far the last 2 weeks I talked about point estimation. So we talked about bias, MSC, unbiasedness, asymptotic unbiasedness, consistency, and so on. But what I haven't talked about is how to construct estimators. How to construct estimators. Now, there are many methods in statistics for constructing estimators. One of the most popular methods for constructing estimators is known as the maximum likelihood method. And that's what I'm going to talk about today, right? Right. The method of maximum likelihood is basically has 4 steps, right? It has 4 steps. And okay, suppose you have continuous data, IID, from a continuous distribution with the density given by this, right? The first step is known as, this is the first step, right? You compute what is known as the likelihood function, which is taken to be the product of the density function for I from 1 to m. So the product is over the n data points, x1 to xn, right? Okay. The second step is to take the log of the likelihood function, that is the log of this, which becomes this. And the third step is to differentiate the log likelihood with respect to theta, which is the unknown parameter. So as I said here, the random sample is from a continuous distribution with this PDF, which is parameterized by theta, right? So what we're trying to do is trying to find the MLE, or the maximum likelihood estimator of theta, right? So that's the third step. You differentiate the log likelihood and set it equal to 0 and solve for theta. Now the final step is that if theta hat denotes the solution of star, right, then it's an MLE if the second order derivative of the log likelihood at theta equal to theta hat is negative, right? All right, so there are 4 easy steps to find the MLE, or the maximum likelihood estimator of a parameter theta. All right, that's for continuous data. Now for discrete data, if you have discrete data, the only difference is that the data, again, IID come from a PMF, not a PDF, right? This is the probability mass function. Again, parameterized by theta. Theta is a parameter that you want to estimate. Okay, and so the steps are similar. The only difference is that PDF is replaced by PMF. So this is the likelihood function, the product of the PMF, and this is the log likelihood function. And the third step, you differentiate the log likelihood with respect to theta, set it 0, and solve for theta. And in the final step, you say that the solution of star is the MLE if the second order derivative at theta equal to theta hat is negative. All right, guys. Any questions so far? Just use the chat room, guys, okay? And the next thing I want to talk about is some properties of MLE. The first property is that the limit of the bias of the MLE as n approaches infinity, n is the sample size, is equal to is equal to 0. So in other words, theta hat is asymptotically unbiased, right? Okay, theta hat is asymptotically unbiased. The second property is that the limit of the MSC of theta hat as n approaches infinity is 0, which means that theta hat is consistent for theta. And the third property is that root of n is the sample size, times theta hat minus theta approaches the normal random variable as the sample size approaches infinity. And this property is known as asymptotic normality. All right, and the fourth property is that if G is a one-to-one function, right, then G of theta hat is the MLE of G of theta. And this property is known as the invariance property. All right. Now, I'm sure you guys know from analysis what a one-to-one function is, right? Or don't you? A one-to-one function is that for every x, there's only one y, right? So for every x value, there's only one y. It's known as the one-to-one function. All right. So these are 4 properties of MLEs, and you don't need to know the proofs of any of these properties, but you should know how to apply. You should know how to apply these properties if I give you an example. I mean, I will do plenty of examples as usual, right? Okay. I'm not sure what injective is, Will. I'm not sure what injective means, but one-to-one means that one-to-one means is basically for every x, there's only one. For every x value, there's only one y value, and that's what one-to-one means, right? I'm not sure about injection or bijection. I'm not sure. It's a long time since I did analysis, so I don't remember what injection or bijection is. But All right, guys. So this is the video I wanted to talk about. All right, now let me do some examples, as many examples as I can. Now, if you go to the next week's video, you will see I have done 10 examples already. So this is basically example 11. All right, so it says here, you have a random sample with IID means independent and identically distributed with the PDF given by this. And the question is to find the MLE of theta. So the first step you need to do is to write down the likelihood function of A, which is the product I from 1 to n of right. This is the likelihood function. Now, if you simplify this, guys, you get one. This is what you get. Okay, so that's the first step. The second step is to take the log of the likelihood function. So log of L of A, right? So it's the log of this function. So it's gonna be minus n log A minus 1 over A yeah, this is the log of the likelihood function. And the third step is to take the derivative of the log likelihood with respect to the parameter, which is A in this case, right? So this will be minus n over A plus 1 over A squared times the sum of xi, right? And you set this to 0 and solve for A. So if you put this equal to 0 and solve for A, you will get, it's easy to see that A hat, the solution, the solution, you always say, put a hat on top, right? The solution for this is A hat, which is equal to 1 over n times the sum of xi, which is basically the sample mean, you may recall. All right, now to the final step is to make sure that this is a MLE, to make sure this is, it is not clear now. Are you guys having problems seeing the video? Zian, what's okay, sorry. Okay. All right, so you need to do the second order derivative, right? So the second order derivative is the first order derivative of this, which is n over A squared minus 2 over A cubed what is that root? Why is that a root? Why, Sophie? What I have done, Sophie, is that this is the first order derivative, right? And I put that equal to 0. And if you solve this for A, you will get A hat to be equal to this. So this is the root of this equation for A. Can you see that? In the second is minus, yeah, it's minus NA minus this, yeah, that's the log of this, guys, right? And in the third step, what I have done is to take the derivative with respect to A. So you get this minus n over A plus 1 over A squared times this. right? And to answer Sophie's question, now if you put this equal to 0 and solve for a, you get a hat equal to this, right? Can you see that, guys? Yeah. Okay, now in the fourth step, what I'm trying to show is that I'm trying to show that the second order derivative is negative at a hat, a equal to a hat. So I took the second order derivative, which is this, right? Now I need to show that this is negative, right? One way to do that is as follows. I'm going to pull out this, right? Then you get in brackets, you have this, right? Correct me if I'm wrong. Right now I'm gonna replace a by a hat, right? So this guy here will become a hat cube minus n a hat minus 2 times the sum of xi. You guys follow me? Right, now we know from step 3 that a hat is equal to 1 over n times sum of xi. So n times a hat is n times a hat is gonna be sum of xi minus okay. Yeah, you put the hat. Could you please explain how you differentiated part in 3? Okay, I will explain that now. Now, if you could, you mean from step 2 to step 3? Is that what you're saying? Yeah, step 3 to 4. All right, 3 to 4. All right, so the derivative of minus n, the derivative of minus n over a with respect to a is n divided by a squared. And the derivative of 1 over a squared with respect to a is minus 2 divided by a cube. Right? Is that right, guys? I mean, this is simple. I mean, you should differentiate minus n over a with respect to a. You get this, right? Is there somebody in the waiting room? I cannot see anyone. Come on, guys. Is there somebody waiting? Okay. All right. Now, another question I just had is when you take the log of 1 divided by an, you get minus n times log a. Do you see that or no? If you take the log of this, you get minus, because what you have here, guys, is a power minus n. So the log of that is minus n times log a. Before an equal sign is exact and not. Any other questions, guys? Are you with me or no so far? Now this guy here, because this is the same as this, you have sum of xi minus 2 times sum of xi, which is clearly negative, because, right? And so one person asked me why we need step 4, because that is part of the scheme. Every scheme for finding an MLE must have 4 steps, step 1 to step 4, right? So since this is negative, we have shown that A hat given by X bar is an MLE. All right, so this completes example 1. John, no, A hat can be positive or negative. What you need to show in step 4, John, you need to show that the second order derivative is negative. Yeah, but in this case, A hat is positive because it's a sum of xi. In this case, A hat, you're right, yeah. A hat is positive because xi are positive. Remember the exponential distribution for the exponential for this PDF, x is greater than 0. So which means that A hat must be positive, right? And hence this guy here must be negative. And hence this is an MLE of A. Yes, you are right, Duo. If this is positive, then it cannot be an MLE. So the second order derivative must always be negative at the MLE. I have a question from, why is it NA hat equal to the sum of xi? I thought I explained it here, Robert. If you put this equal to 0, Robert, you get the solution A hat equal to this. All right, okay. That's because A hat is equal to this, Robert. So n times A hat is equal to the sum of xi, right? So you can replace NA hat by the sum of xi because of this, right? Because of this statement here. Okay. Any other questions, guys? I want you to get this right because you will have you will have a quiz on MLE later on in this semester. So please, are you okay with this, guys, or not? Any other questions? I'm disappointed with the number of people turning up for the review session. It's getting less and less every week. Are you okay with this example, guys, or not? Any? Okay, thank you. All right, so this is example 1. The next example I want to do is this example here. Example 2. Suppose you have data from Ln stands for log normal. I don't know if you did this in probability 1. Did you do log normal in probability 1? Or maybe not. So anyway, if you did not do, I will write it down. PDF of Ln with these parameters is this. This is the PDF of a log normal random variable with parameters theta and 1. Right? Okay, now I want to show you how to find the MLE of this, right? So the first step number 1 is to write down the likelihood function, which is the product of this times this. Okay. Now, if you take the product of this, this is what you will get. You will get 2 pi, all right, times, all right. I mean, if you have any questions, please feel free. All right, so this is the product of the likelihood function. I mean, this is the likelihood function, I mean. All right, step two is to take the log of the likelihood function. So it's the log of this guy here. So this is minus the sum. Remember the I don't know whether you know the log of a product is the sum of the logs. If you go to the course website, I given you properties of products and sums. I think there are 2 videos. I did two different videos on properties of sum and properties of products. Yeah, the n over 2 comes because of the square roots. You see, you have a 2 pi, square root of 2 pi. So when you take the product of that, you get 2 pi power n over 2. Because 2 pi is, you have a square root, right? So the product of a constant is, I'll come back to that in a sec. Let me finish this now. This is where the property is really useful. I mean, if you go back to the course website, there are 2 videos. One video on properties of sum, another video on properties of product. I suggest you watch those videos, and it gives you how to simplify products or how to simplify sums. Oh, are there people waiting? Just a minute. I cannot see anyone waiting. How do I let people in? I'm not sure. Wait a minute. Oh, okay. Thank you. Okay. I found it now. Okay, thank you guys. Thank you, John. This is week 6, guys. Week 6. This is week 6. But you should go to the preliminary section. You should go to the preliminary section of the course website. You will see there are 2 videos. One on properties of sum, another on properties of products. I suggest you watch those 2 videos. Otherwise, you will find this struggle. You'll find this a bit of a struggle, right? Okay, right. So part three is to take the derivative with respect to theta, right? Now, if you take the derivative, this is a constant, this is a constant. Now the derivative of this is gonna be minus 2. I'm using the chain rule. This is what you will get, right? All right. So this, you set this to 0 and solve for theta. So this becomes 2 times the sum of log of xi minus theta is equal to 0, right? Okay, I think I have let everybody in. Kieran, I think I have let everybody in. Sorry. right now. So I apologize for not. Yeah, you could take the -1. Yeah, you could put the -1 in front. Yes, yes, you are right, man, Mikhail. Yeah. So this implies that the sum of log of xi minus theta is 0. All right. So this implies that the sum of log of xi minus the sum of theta, which is n theta, is equal to 0. Right. So this implies that the solution for theta, let me call it theta hat, is equal to 1 over n times the sum of log of xi. Okay. All right, guys. Are you with me so far or no? Hello, guys. This is the solution for this equation set equal to 0, right? Okay. Right, now that's step number 3. We are not done yet. Now step number 4, which is always needed, is to do the second order derivative. So I'm going to do the second order derivative with respect to theta, right? So that's the first order derivative of this. So what you're gonna do is you're gonna differentiate 2 times d by d theta of log of xi minus theta, right? Right, now this is gonna be plus 2 times d by d theta of the sum of log of xi minus the sum of theta is n theta, right? Now this is a constant, and the derivative of minus n theta with respect to theta is minus 2n, and this is negative. So hence, right, is all right. Are you okay with this, guys, or not? I mean, is this example clearer, or you have questions on this? Hello, guys. It's clear. Is there a minus before the sum? What do you mean minus before the sum? Yeah, there's a minus which cancels out to become plus. There's a minus here and a minus here, so you get a plus 2, right? So that's why you have a plus 2 here. So this is plus 2, not minus 2, plus. Is that what you've done? It's minus 2n because the derivative of minus n theta with respect to theta is minus n, right? So you have 2 times minus n, which is minus 2n. Yeah. Can you explain step 4? Step 4 is all right. The step 4, what I have done, guys, is to differentiate this guy here with respect to theta, right? Now what you have here, guys, is 2 times the sum of log of xi minus theta. I mean before the sigma. What do you mean? Before the, okay, I mean before the sigma, it is a dot or minus sign. I don't understand your question, Louis. Louis, what do you mean? Step 3. This is step 3, guys. This is step 3, right? Yeah, but this is step 3. Step 3, we got the solution for theta hat, which is equal to this, right? Now in step 4, what I've done is to differentiate this guy here with respect to theta. That's what I'm doing here, right? Okay, now this guy here is a constant. This guy is a constant, so the derivative of a constant is 0. We don't need to bother about this because this is constant. And so you only need to bother about this second term here, minus n theta. And the derivative of minus n theta with respect to theta is minus n. All right, so 2 times minus n is minus 2n, right? So which is a negative number because n is positive. N is the sample size, it must be positive. So hence we have shown that the solution for part 3, which is this, right, is an MLE, right? Is that clear or not? I know some of you are asking me questions, but I'm trying to answer them as I. Yeah. Mikhail, is that clear, Mikhail, or not? Okay. I got a question from Louisa. I mean, the sigma is a dot or minus sign before. There's no dot before the sigma. It's just you're just trying to. I'm just trying to find the derivative of this, Louisa. I don't know what you meant. There's no dot. I can't see any dot here. Okay. All right. Okay. Thank you. So this is example 2. I mean, it's good that you're asking questions here so that I can try to explain them. So let me do just one more example. I think I'm running out of. This is example 3. Example 3. Again, here we have a random sample from a log normal with parameters 0 and theta squared. So in this case, the PD, if you haven't seen the log normal in probability 1, this is 0. This is the PDF of this guy is all right. This is the PDF if you haven't seen it before. All right. Okay, guys. So let me put this in a box. Okay. Now I want to show you the 4 steps. The first step is to write down the likelihood function, which is the product of the density function. Right, this is the product of the density function. Now, if you take the product, this is where you need to watch my video, guys. Please, you should go to the preliminary section of the course website. There are 2 videos I would like you to watch. The first video is called Properties of Sum. The second video is called Properties of Product. So please watch those videos, otherwise you will struggle. You will struggle with this. So those two videos are in the preliminary section of the course website, right? So this simplifies to this, right? Okay. Next, part two, or step two, is to take the log. I missed out. There should be a theta here. Excuse me. There should be a theta here. I missed out. So this should be, there should be a 1 over theta power n. There should be a theta here. I missed out. Excuse me. All right. So you should take the log of the likelihood function. You get minus. All right. Okay, guys. So this is the log of the likelihood function. Or what is power theta? Is n, sir? Is n theta power n? Theta to the power n, sir. Yeah. Yeah. All right. So part three is to take the derivative of the log likelihood with respect to theta. Now the derivative of this is a constant. This is a constant. So the derivative of this is minus n divided by theta, and the derivative of this with respect to it doesn't matter, Vikram, either there's theta or theta squared is the same, because theta squared is a one-to-one function of theta, so it doesn't really matter. All right, so the derivative of this with respect to theta is 1 divided by theta cube okay. Now you set this to 0 and solve for theta or theta squared. Doesn't matter, because theta squared is a one-to-one function of theta, because theta is a positive number. All right, so if you solve this for theta squared, I'm going to put a hat on top. It's going to be 1 over n times the sum of log of xi squared. All right, are you okay so far, guys? All right, now I'm going to do step 4. Step 4 is where we need to show that the second order derivative is negative, right? So let's do that. Step 4. So the second order derivative of the likelihood, right, is the first order derivative of this. So if you differentiate this with respect to theta, you get n over theta squared. Differentiate this with respect to theta, you get right. Okay. Now I need to show that this is a negative number. All right. I mean, there are several ways you can do this. One way is as follows. I'm going to pull out this as a common factor. So you get n theta squared here minus 3 Vincent. Yeah, can you see it again? This is the solution for part 3, right? I'm trying to do part 4, right? Now I'm going to replace theta squared by theta squared hat. Can you see it? I'm going to replace theta squared by theta squared hat, which is given by this, right? So now we know from here that because theta squared is this, n times theta squared hat is this guy here, right? So we can replace n times theta hat squared by this guy here, right? All right, so okay, you follow me? Do you see how I got from this line to this line? It's because once again I have used this fact here, that is because theta hat squared is equal to this, n times this guy must be equal to the sum of the squares of log of xi. All right, now what you see here is you have this term minus 3 times the same term, so this is clearly minus 2 times right, and this is clearly negative, right? Because I mean, this term is clearly positive. This term is clearly positive. 2 is a positive number, so this must be negative, right? So hence, sorry, theta squared here. Right. All right, guys. So this completes example 3. Are you okay with this, guys, or no? Hello, guys. Talk to me. Are you okay? You sure? All right. I can do one more example if you have time, or do you want me to close the session now? I can. Do you want me to do one more example, or have you had enough of me? I know I only have 1 minute left, so yes. Okay, let me do one more example if you don't mind. Yeah. Okay. I always try to do as many examples so that. Okay, so this is the example number 4. So I will do it quickly. I don't want to take your. You may have other things. We have a review. Sorry, tutorial session in 10 minutes time. All right, so just wait for that. So the PDF here is a times x power a minus 1, right? Could you please give the answer for the review session last week? What do you mean? I don't understand. Well, you mean the answer for the last example I did? Well, that is actually that's actually the quiz number 5, so I'm not allowed to give the answer. If you look at quiz 5, is the example I did not complete last week. It's the same as quiz number 5. So I will not, I cannot give you the answer because quiz 5 is due on Thursday this week, as you know. All right, so this is the likelihood function, and the log likelihood function is n times log a plus a minus 1. Yes, I understand, sir. I left example 14 because example 14 is the same as quiz number 5. Example 14 is the same as quiz 5. So I'm not allowed to give you the answer, guy. I will give you the answer. Okay, so this is the log likelihood. And step 3 is to take the derivative with respect to a. So you get n divided by a plus the sum of log of xi, right? And set this to 0 and solve for a. You get a hat equal to minus n over okay. So this is the solution of this equation here, right? Now step 4 is the second order derivative with respect to a. So the second, this is a constant. So the only thing that you're differentiating is n over a, so which is n over a squared. And this is clearly negative, right? All right, so hence the conclusion is that a hat equal to this is NMLE of A. All right, sorry for taking your time, but this completes example 4. Are you okay with this, guys? Hello, guys, are you okay? All right, so let's, so this is the end of review session. I will, there's a tutorial starting in about 7 minutes time. So I will see you there, guys, okay? Have a good day, guys, wherever you are.
Thank you.
Bye.